Thank you for stopping by, guys. In this video, I just wanted to give you an update on BBSA 3.0 version project that I've been working on for a little while now. So this is similar to SOTA Instruments Silver Pulsar. It's from the Dr. Bob Beck protocol. This device is used to produce colloidal silver water and also for micropulsing to boost immune system. This is the open source version. I started up with this board here, and after testing it, I found some things I can improve. So I found a better boost converter. This is 27 volt. I have figured out how to boost it, how to override it to 30 volts. That's originally reason why I didn't want to use this one in the very first design, but this one is way more efficient, power efficient, and also added a chip for a low voltage battery and changed some components around on these boards in a modified version, and was able to boost running time from 24 hours around there on this one, same battery, boosted to a little over 200 hours, so 8 times. So if you use it 2 hours a day for about 2.5 months or so, you'll get so runtime non-stop a little over 8 days on this battery with this. And then another issue I had is this charge. This is USB-C charge controller, and as is, it's set to charge with about 1 amp of current, and that heats up the chip. And if I would have it all in one case, it would generate quite a bit of heat inside the case, and so I had to figure out how to lower the charge current. And on this new version, which is second board, right, this one is red, this is the white board, I lower the charge current about 4 times, so it takes about 10 hours to charge this battery. I figure because this battery doesn't need to be recharged often, like once every 3 months, 10 hours is okay. So also figure out how to boost from 27 to 30 volts running voltage for micropulsing. Also, what else I did? Redesign this board. You can see this is slightly different than this. I'll replace the chip. This is a 30 volt chip, LM358L, and this is LM358N chip. This is a little more expensive chip, but it can work with higher voltages. Not as efficient as that one, maybe a few percent less efficient, but it's more reliable. Printed some spacers for the LEDs and getting ready to design a case for this model. By the way, along with this project, I am working on a second generation Silver 8, and that one's coming along nicely. I'm almost finished with that one, just need to design a label, and that one will go into production probably in a month or so. This one, I am getting ready to start designing the case for this one, and this is the open source one. The second generation is not open source. So with this one, you will have access to source, where you can source all these components, even the files for 3D printing case, and you can print it yourself if you have a 3D printer. Basically everything with the schematic, everything is going to be open source for this model. This model versus the second one has a little larger battery, so, and also has a low battery indicator. So when battery goes low, this red LED will start blinking. That is a chip to monitor a battery. When the battery drops down, it triggers the LED to start blinking. This is LED for colloidal water. This is intensity adjustment. And yeah, and this one will be a bit more compact, I hope so, than this. So this is just an update on this project. Yeah, and on this board I also found an error that I did. You see this jumper here, I had to reverse these pins, and so I already ordered a new board which is going to be in a green color. It's coming in a couple of weeks or so, and I will be selling that board as the latest one, with components, without components, however you want. Altogether, with the components and the battery as is, this setup cost around $8 or something. I will add a little percentage on to cover my time, and probably about $15 I will be selling everything like this, plus case is gonna be a few dollars more. But yeah, this is what I'm at with this project. It's been taking me a while and quite a bit of investment already. Like every time I have to design a new board, it costs like a couple of $100. So I'm on a third board right now, and buying a bunch of components. I bought enough components for about 100 units, so I will have plenty in stock for second generation and this third generation pulsars. So yeah, I will update you guys when I have the case ready for this, and hopefully it won't take long. That's about it. Thank you for stopping by, watching my videos. Subscribe for more, and I'll see you in the next one.